Hi everybody, in this video I'm going to be showing you how to expand binomials. First things first, what is a binomial? A binomial is an algebraic expression that has two terms. For instance, that is a binomial. This here is a binomial. It has two terms. This is not a binomial because it only has one term. But I could add another term and it would be a binomial. When we're talking about binomial expansion, we're talking about what happens when we raise that expression to some power. Now, the greatest mistake that you can make is to think that a plus b to some power is equal to a to that power plus b to that power. That is not correct, not at all. And you know that that's not correct because when we learned in previous years, a plus b all squared, well, what does that equal? That is equal to a plus b times a plus b. And if we use FOIL, we'll see that that's a squared plus ab plus ab plus b squared. So it's a squared plus 2ab plus b squared. Now, if we were to just say that a plus b all squared is equal to a squared plus b squared, that would be absolutely wrong because it leaves out this part here in the middle, 2ab. So when we're expanding a binomial, a plus b to some power, it is much more involved than just applying to this power to both of the terms. Okay, you would have heard of Pascal's triangle. Pascal's triangle is key to expanding binomials. Let me show you how it goes. We start with ones like that. Then we have 1 there, and then this next number here is going to be the sum of those two. So that is going to be 2, and then we put a 1 on the side. Then we put a 1, and then our next number here is the sum of those ones, and that one is the sum of those ones, and then another 1 on the end. And we go these ones, these ones, these ones, and these ones, and we keep going like that. Write down. Now you're going to need to be able to write out Pascal's triangle to row 7 or 8 pretty quickly. So this would probably be a good time to pause the video and give that a go. See if you can get, say, 7 or 8 rows of it done in maybe under 30 seconds. Okay, hopefully you had some success about that. Now, when we were expanding our expression, a plus b all squared, note here that our power is the power of 2. Now, the row on Pascal's triangle that we're interested in is that one there. That is row number 2. We're interested in row 2 because of that power is squared, power of 2. Now, 1, 2, 3. 1, 2, 3 terms in this expression. Now, I put down my coefficients here. 1, 2, 1. Notice that? Matching these numbers here. Now, here, I'm going to add a to each of these. And I'm going to add b to each of these. Now, when I'm applying my powers to the first one, I go the largest power, and then I count down my powers till I get to 0. So I'm starting this term here with the largest power of that one, which is that. Now when I'm doing my b term, I'm going to start at this end and count down this way. Now all of us will know about the rule about power of 0. That is, anything to the power of 0 is equal to 1. So I don't actually have to put that one there in at all. Similarly, I don't have to put that one there in at all. Now, if we have a coefficient of 1, we normally don't write it, do we? Also, when our powers are 1, we don't normally write them either. A to the power of 1 is just a. Now, all of these terms are positive, so I put pluses in between, and you'll see here, a plus b squared is a squared plus 2ab plus b squared. What about this next one? If I want to do a plus b to the power of 3. Now the first thing I ask, how many terms will this have? Well, a plus b to the power of 3 relates to this row here. The coefficients are 1, 3, 3, 1. It's going to have 4 terms, so I put my 4 lines like that. I'm going to write my coefficients in. 1, 3, 3, 1. Now, I don't bother writing the 1s because a coefficient of 1 doesn't really need to be there. Then what I'm going to say is, well, I start with my highest power. My first term highest power is 3, and then I count down my powers here. A to the power of 1, a to the power of 0. Now, I don't write in a to the power of 0 because I know that that is just 1, and I remove that 1 from there because I don't need it. Next, I'm going to start over here at this end. It's my second term to its highest power, and then count down those powers there. But again, I don't need to write the power of 0 in, and I don't need that little 1 there. All these terms are positive, so I've got pluses in between them. And that is how I expand a plus b to the power of 3. Now let's just change it slightly. What would happen if instead of a plus b, it was a minus b to the power of 3? Well, again, we're going to have 4 terms, and our coefficients are going to be the same as before. We're going to have the first term raised to the third power, descending powers like that. And here we're going to have our second term. Now I'm thinking of our second term here as negative b. Negative b to the power of 3, negative b to the power of 2, negative b to the power of 1. Okay, and I can think about these still then as adding in between. See what I've changed that to? I've said a plus negative b, all to the power of 3. Now let's think about what this means. This here, negative b to the power of 1, well, that's just going to be negative b, isn't it? So what I can actually do is change that one a little bit. I can put the negative out the front here, still got a cubed there. That's going to be negative of a squared b. Now this next one here, negative b all squared, is just the same as b squared. That's positive. So this one's going to be positive. And what about this one here? Well, negative b to the power of 3 equals negative b times negative b times negative b, which is negative. So that one is going to come out as the negative of b cubed, like that. Now notice here that instead of doing all of this stuff with the brackets, I can just change the sign on this one, and this one. And that's actually how it always is. Just have a look at this. If I've got a minus b to the power of 4, well, first thing I ask myself, how many terms does it have? It has 5 terms. Notice the power of 4 has 5 terms. The power of 2 has 3 terms. The power of 3 has 4 terms. Put in my coefficients from Pascal's triangle. 1, 4, 6, 4, 1. I'm just going to do my descending powers of a. It's going to be 4, 3, 2, 1, 0. Now, here if I look at my powers of b, negative b to the 4, negative b to the 3, negative b all squared, negative b to the power of 1. Which ones are going to be positive and which one's going to be negative? Well, it's going to be the odd powers that are negative. Okay, so this one here is going to be negative, and so is that one. So it's going to be a to the 4, and then there's going to be minus this one here, plus the next one, minus the next one, and plus the final one. This one's going to be positive because negative b times negative b times negative b times negative b ends up positive. Did you notice that again, it's every second one is negative, starting with that second term? That's the way that it always is. If I've got a minus b, say to the power of 17, the first one, there's going to be a lot of terms here, that first one is going to be positive, then there's going to be a negative there, plus here, minus here, plus here, minus here, plus here, and all the way along. So it starts with that second term there is negative and goes minus plus after that. Okay, how would we expand this here? 3x plus 2 all to the power of 6. First thing I ask, how many terms will it have? It's to the power of 6, so it will have 7 terms. Okay, now it's positive here, so all of them are going to be positive. I'm just going to put those pluses in straight away. Now, the next thing I need to do is go to Pascal's triangle to get my coefficients. If you don't already have it written, you'll need to write it again. Okay, there it is there. That is the row we want because it's power of 6. And I'm going to put in those coefficients. 6, 15, 20, 15, 6, and 1. Now, I'm actually not going to worry about that expression as it is yet. Instead, I'm going to think about a plus b to the power of 6. So what happens? I'm counting down my powers of a, starting with 6. 6, 5, 4, 3, 2, 1, 0. And then I'm going to start over here and count down my powers of 6. Powers of b, sorry. Okay, now what am I going to do next? I'm going to need a bit of room now because I've got to do some substitution. I know in this case that a is equal to 3x and b is equal to 2. So what I need to do now is go and do those substitutions. So this first term here is going to be 3x all to the power of 6. Then I'm going to have plus, well, what's it going to be? 6 lots of 3x to the power of 5, lots of the b term, which is 2. And we're just going to keep on going through like that. 15 lots of 3x to the power of 4, b to the power of 2. I'm going to keep going with that. Now, I'll encourage you to make sure that you put brackets around that 3x because it's the whole thing that we are raising to the power. And we keep on going like this, and it's a bit tedious. We've got 3x squared, and 2 now is to the power of 4. 3x, and then we've got times 2 to the power of 5, and then plus, and it's 2 to the power of 6. Now I'm going to use my calculator for the next one here. I need 3 to the power of 6, and that's going to be 729 x to the power of 6. Next one I have to type in 6 times 3 to the power of 5 times 2, 2916 x to the power of 5. Next one, what am I typing in? 15 times 3 to the power of 4 times 2 squared. And the numbers here get quite big. Not forgetting my x to the power of 4 here. What's next? 20 times 3 to the power of 3 times 2 to the power of 3. 4320 x cubed. Next one, what am I doing? 15 times 3 squared times 2 to the power of 4. 2160 plus 18, 6 3s are 18 times 2 to the power of 5. Oops, better not forget the x squared there. 576x, and then plus 2 to the power of 6, which is 64. Okay, so that is the expansion of that expression that we started with. Can you see how wrong it is to say 3x plus 2 to the power of 6 is equal to, well, 3x to the power of 6 plus 2 to the power of 6? Absolutely wrong. If we did that, we would be missing out of all of this content here. Okay, let's think now what would happen if we changed just one thing. What about if instead of plus here, scrub that out, instead of plus there, we change that to minus? What would change? Well, the only thing that would change is a few of these signs. So this one here would be negative, and every second one would be negative. So I just have to scrub those ones out and replace those with negatives. So it goes minus, plus, minus, plus, minus, plus. And then again, we do that on these extra lines here. So the final answer would be the same, apart from a few negatives, which we'd need to add in. There, there, and there. That one, and that one. That's the only difference it makes if it's a minus there instead of a plus. Okay, now it's really tedious expanding all of those out, but you might get a question like this. Find the fourth term in the expansion of 5x minus 3 to the power of 7. Okay, here's how I go about that. I'm thinking it's to the power of 7, so we're going to have 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. And which are we after? 1, 2, 3. We are after this one here. Now, I need to find the coefficient of that term, and I look up my Pascal's triangle, draw it if I need to, and I'm after 1, 2, 3, that number there, 1, 2, 3, this one here. So my coefficient here is 35. Now, I'm thinking about my powers, so how am I going to do this? My powers descend a to the 7, a to the 6, a to the 5, a to the 4. I don't need to go any further than that because that's all I'm interested in. These ones start at this end, b to the 7, b to the 6, b to the 5, b to the 4. What's this one going to be? b to the 3. Okay, so here for this one, and I'm just going to check first, would it be plus or minus? Well, it's a minus here. That one's going to be minus, this one's going to be plus. I'm imagining it's going to be minus, but I can check on that. I think it's going to be negative. So we've got 35 times our a term. Now our a term is 5x. And that's to the power of 4. Times our b term, which is, well, we could think of it as negative 3. And that's going to be to the power of 3. Well, negative 3 to the power of 3 is going to be negative, isn't it? So what I'm going to do now is just I'm going to rub out that negative there and pop it out the front there. Just like we expected, it's a negative. Then I'm just going to feed that into my calculator. Now, if this was a tech-free exam and you didn't have a calculator, they asked you what the fourth term was, that is what you would give them, just like that. But I do have a calculator on me, so I'm going to evaluate that. Negative 35 times 5 to the power of 4 times 3 to the power of 3. And that gives me negative 590625. And I've got x to the power of 4 in there as well. Okay, now this one here is one that you're going to want to use your calculator to help you with rather than Pascal's triangle. It says find the fifth term in the expansion of 2x plus 3 to the power of 12. Now, I don't want to draw Pascal's triangle right up to row 12, so I'm going to need another strategy. Here's what I'm going to do. I'm going to start by just representing the first 5 terms like that. This is the one that I'm after. Now, I know that it keeps on going for a long time after that. But what I'm after is I'm on Pascal's triangle row 12. And this one here, the coefficient of this one is what we choose called 12, choose 0. And I know that that is 1. It's always 1. That's that edge number. This one here is row 12, position 1. And that would be 12. This is 12, choose 2, 12, choose 3, 12, choose 4. Okay, so I go to my calculator and I'm looking for the NCR function. This one here is row number, and this one here is our position on the row. And remember that the position, this is position 0 here. So if I'm after the fifth term, it's going to be 5 minus 1 is 4. So I go to my calculator and I'm finding 12, choose 4. And that coefficient is 495. See why I didn't want to draw all of that? Now I'm going to have my A term, I'm going to think about my A term next. And that's going to be a to the power of, well, what's going to be 12, 11, 10, 9, 8. Then I'm going to think about my B term. And remember here I can count up from 0. 0, 1, 2, 3, 4. B to the power of 4. Now notice that these two numbers here add up to 12. They always add up to 12, both of them. So this one here, for instance, is going to be the A term to the power of, well, what is it? 12, 11, 10. This one's going to be the b term to the power of 0, 1, 2. 10 plus 2 is 12. Okay, so I've got for this term here 495 times a. A is 2x to the power of 8 times our b term, which is 3 to the power of 4. And I can just type that in my calculator to find out what that term is. And here is my answer. Here's one for you to try. Press pause and give it a go. Okay, well, here's how I do it. I'm after term 7. 1, 2, 3, 4, 5, 6, 7. This is the one here. And for my coefficient, it's going to be, well, it's going to be 13. Choose, well, which position number? 0, 1, 2, 3, 4, 5, 6. 13, choose 6. Now, for the 7th term, notice that that one there is 6. So it's going to be 13, choose 6, then it's going to be a to the power of, well, what's it going to be? 13, 12, 11, 10, 9, 8, 7. And it's going to be the b term to the power of 6. Now notice that that 6 there is the same as that 6 there on the 13, choose 6. So I go to my calculator from here, and I'm going to go 13, choose 6, and that gives me 1716 times the a term, which is 5x, and that's to the power of 7, times the b term, negative 3. I'm just going to put that in there like that, negative 3 to the power of 6. Now, is this term going to be positive or negative? Well, if I've got negative 3 to the power of 6, that's an even power, so that's going to come out as positive. Pop it into my calculator here. And that is, well, we have it in scientific notation, which is 9.77 times 10 to the power of 10. So that's a really big number. Oops, almost forgot, lots of x to the power of 7. Okay, here's a slightly trickier problem. 216x is a term in the expansion of 2x plus c plus something to the power of 4. Find the value of c. So what we are looking for is this here. Okay, here's how I do it. Well, we are at the power of 4, so how many terms are we going to have? We're going to have 5 terms. Put them in. And we're power of 4, so what will our coefficients be? Back to Pascal's triangle for that. 1, 4, 6, 4, 1. Okay, now what I'm thinking here is, well, this is going to be the first term to the power of 4, power of 3, power of 2, power of 1, and this one here is going to be the second term to the power of 4, power of 3, power of 2, and power of 1. Okay? Now what we're looking for is which of these terms could possibly be negative 216x. Well, I look back and I see that I've got 2x there, so I've got x. Which one will just have x to the power of 1 in it? Well, that one's going to be, it's going to be this one here. That's our a term raised to the power of 1. So it's going to be this term here that I care about. And that's going to be 4 times the a term, which is 2x, just to the power of 1, times the b term to the power of 3. And I know that that equals negative 216x. So I'm just going to evaluate this now. This is going to be 8c cubed x equals negative 216x. Cancel those x's. Divided by 8, negative 216 divided by 8 will give us c cubed equals negative 27. Well, c then is going to equal the cubic root of negative 27, which is negative 3. So this c here is negative 3, and that is our solution. Here's one for you to try. Press pause on the video and see how you go. Okay, so first thing I do is we've got the power of 3 here. How many terms will it have? 4 terms. What are the coefficients? 1, 3, 3, 1. Okay, what am I doing next? Which one will have an x squared in it? Well, this one here is going to be 5x to the power of 3. This one here is going to be 5x all to the power of 2. So it's going to be this term here. Now, this one's going to be c to the power of 3, c to the power of 2, c to the power of 1. So, simple as anything here, this term is 300x squared. So 300x squared equals 3 times 5x all squared times c. So that's going to be 5 squared is 25 times 3 is 75. 75cx squared, 300x squared, cancel out my x squareds, divide 300 by 75, and I get c is equal to 4. Is that what you got? Okay, here's another one for you to have a go at. Notice here that the difference here is that we've got a squared inside there. Press pause. Okay, as always, I start by thinking how many terms are there? Well, there's going to be 8 terms. Okay, and which term am I after? Well, this one here is going to be 2x squared to the power of 7. So that is actually going to be the x to the 14 term. This one here is going to be 2x squared to the power of 6, which is going to be the x to the power of 12 term. This one here is going to be 2x squared all to the power of 5, which is the x to the power of 10 term. So this one here is the one we want. Okay, so Pascal's triangle, what is the coefficients? We're going to go 1, 7. Now, I don't have Pascal's triangle drawn neatly up at the moment, so I'm going to use my NCR function on my calculator. It's going to be 7, choose. Well, this is position 0, this is position 1, this here is position 2. So it's going to be 7, choose 2, and I'm just using my calculator for that. And that is 21. So I've got 21 lots of 2x squared all to the power of 5. Now, what is my b term, which is c in this case, going to be? Power of 1, power of 0, power of 1, power of 2. There we are. And notice that these two powers should add up to give me 7, and they do. So, using my calculator now, 2 to the power of 5 is 32, times 21 equals, so that comes to 672 c squared x to the power of 10, and that is equal to this number here, 16800 x to the power of 10. Cancel out those x's, divide 16800 by 672, and that will give me c squared is equal to 25. Now, this last step here is where some of you might go wrong. If c squared equals 25, we've got actually 2 answers here. C is equal to plus or minus 5. So this expression could be 2x squared plus 5 all to the power of 7, or it could be 2x squared minus 5 to the power of 7. And that is because this term here, the one that we're looking at, that one could be negative, but this one will always be positive, whether or not that there is a plus or minus. So we've got both of these answers. C could be plus or minus 5. Here's another one. Find the constant term in the expansion of 3x squared plus 1 over x all to the power of 6. Now, the constant term is the term that has no x's in it at all. This one will take a little bit of thought, so press pause and give it a go. Okay, here is how I would do it. I'm firstly thinking we're power of 6, so how many terms are we going to have? 7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to go and find my coefficients. Put those coefficients in there. Now, I'm going to need to think about what is happening here with my powers of x. So in this first one here, we're going to have 3x squared to the power of 6, and then we're going to have, none of term b there. This one's 3x squared to the power of 5, 4, 3, 2, and then just 3x squared then. Now what about our 1 over x? So I'm going to just put these on the bottom here. And there's going to be something over here. Well, this is going to be 1 over x to the power of 6, 1 over x to the power of 5, 4, 3, 2, and 1. Okay, now what I'm looking for is when the x's on the top and the bottom will cancel each other out. Can you see where it's going to be? It's going to be this one here, isn't it? Because on the top we've got 3x squared or squared, which is going to be 9, apply that to that and apply it to here, 9x to the power of 4 over x to the power of 4. So this is the term we're looking for. And we've got our coefficient of 15 times by 9, which is 135. So we had to find the constant term in that expression, and that is that one there. Here's another one. Notice that we've got some x squareds on the top and bottom of this. Okay, so how do we do this? Power of 6, 4, 5, 6, 7 terms to it. I'm going to start out not with coefficients this time. We're just going to work out what's happening with the powers. So this is going to be, for this one here, it's going to be x squared on the bottom, 3 over that, and it's going to be to the power of 6, to the power of 5, to the power of 4, to the power of 3, to the power of 2, to the power of 1, and looking at this one here, that's going to be, put these ones in purple, 2x squared to the power of 6, it's going to be 2x squared to the power of 5. Now, what I'm looking for is when the x's on the top and bottom are going to cancel each other out. Are they in this one here? Well, that's going to be 2 5s are 10 on the top and 2 on the bottom. Not at all. Next one, it's going to be 8 on the top and 4 on the bottom. No. What about this next one here? I'm going to have 2x squared to the power of 3 here. 2 3s are 6, 6 on the top, and yes, 6 on the bottom. This is the one we want. So we need the coefficient here. We've got a 6 here, so it's going to be 6 choose 0, 1, 2, 3. 6 choose 3. 2x squared to the power of 3. Sorry, I should have put that wrong order. I've put those in. 1 over x squared to the power of 3. So it's going to be 6 choose 3. Use my calculator for that, which is 20 times, 2 to the power of 3 is 8. 8x to the power of 6. And what do we have for this one here? Oh, now what I did forget here, sorry about that, folks, this is a 3 here, right the way along. So now I'm going to have to be going 3 to the power of 3, that's 27, over x to the power of 6. So those ones will cancel. So 20 times 8 times 27 is 4,320. That is the constant term in that expression. I hope you got that. Okay, here's another sort of those. Negative 80 x to the power of 9 is a term in the expansion of 1 minus 2x cubed, all to the power of n. Find n. So this one here is an interesting one because we don't actually know what power we have raised our binomial to. So let's think about how we're going to do this. Well, it's x to the power of 9 here, and we've got an x to the power of 3 here. So I can go so far as to kind of work out what term in the expansion it's going to be. So this one here is going to be, a to the power of n, a to the power of n minus 1, a to the power of n minus 2. You see, we're counting down our powers there, but can you see what is our a term? Well, our a term is 1. So it doesn't actually matter what power we're raising it to, does it? They're all just going to be 1. And I've only got to really worry about this b term. And I know that this one here is going to be negative 2x cubed all to the power of 0. Negative 2x cubed to the power of 1. Negative 2x cubed to the power of 2. Negative 2x cubed to the power of 3. And we keep on going like that. Now this is the term I want, because if I raise negative 2x cubed to the power of 3, then I get negative 8x to the power of 9. Okay, and it's the x to the power of 9, which is that bit there. So remember though, there is still some coefficient here to put in. And that coefficient is going to be n choose 0, 1, 2, 3. So it's going to be n choose 3 times negative 8x to the power of 9 equals negative 80 x to the power of 9. Okay, I can get rid of those ones. And then I can say n choose 3 equals negative 80 divided by negative 8. So n choose 3 is 80 divided by 8 is 10. Now I can actually use my knowledge of Pascal's triangle at this point to work out what n must be. I recognize the number 10. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. There's our 10s there. So I'm after one of these 10s to be in position number 3. Position 0, position 1, position 2, position 3. That is it. So what row am I on? I'm on this row here. So n is equal to 5. And here's another one of these ones for you to do. Press pause and see if you can get it. Okay, so how are we going here? Firstly, I'm just going to do some dashes for a number of terms. I've got no idea how many I'm going to need. Now, I'm thinking that all of these, because this number is 1, the coefficients for all of these, not the coefficients, the a values for all of these terms will be 1. So I'm only really interested in the b value. So this is the b value here. So that's going to be power of 0, power of 1, power of 2, power of 3. Can I stop yet? Okay, well, I'm after x being to the power of 8. Have I gotten there yet? Yes, I have. It's this one here. 4 times 2 is 8. So it's going to be n, I don't know what n is, n choose 0, 1, 2, n choose 2, 5x to the power of 4, all to the power of 2, is going to equal 375x to the 8. And I just have to solve that for n. So let's see how we go. N choose 2 times 25x to the 8 equals 375x to the 8. What do I do? Cancel out those. Divide 375 by 25. And that will give me NC2 is equal to 15. I'm going to go to Pascal's triangle. And I'm looking for the number 15. Hoping I get to it soon. 1, 6, 15, 20, 15, 6, 1. That's it there. And I'm after one of those 15s to be in position 2. Are they? 0, 1, 2. Great. So what row am I on? I'm on row 6. So n is equal to 6. I have to raise that expression to the 6th power to get this term. I hope you enjoyed that. If you're struggling with this, I'd recommend that you just go back and work the video again, trying every single one of them. Thanks for that.